Now just I was saying you that the energy of a particular shell is quantized, means it has got a fixed value. Quantized means fixed value, not any value of its own. See, theoretically if you see, then you may say to me ki sir, from the nucleus we can have infinite number of shells. Correct, theoretically it is possible, then we can have infinite number of shells, but electrons is not found in all the shells. Electrons are found in that particular shell. Listen carefully. Electron is found in that particular shell whose energy is fixed, which has got a definite value of energy, not any value of its own. Not any value of its own. And its what you can say value is quantized. Quantized means fixed value, whole number. Just now you saw it. What I gave it to you. Alright, just now -1312 kilojoules per mole. I said you the first shell. Then second shell also we can calculate by putting the value of NS2 in the formula. We can calculate it. Alright. In this way, we can say that the energy of a particular shell is always that is fixed. But we can't see the cell. It is this cell. It is imaginary. I told you earlier also. This is imaginary. For just making for me to make you understand, we are saying you this particular thing. It is imaginary completely. This shell, it actually does not exist. Niels Bohr, it said that just to explain theoretically an atom, that electron where it is there present in an atom, or where the nucleus and what the neutrons and protons consist of. So this particular shells, now nucleus is there, of course, the electrons which are moving in a particular shell, that is imaginary. We can say that. So hence I said you discrete what you can say value of energy. For that reason I said. And its angular momentum is also quantized. Now what is momentum? You read in physics this one. Momentum means the product of, momentum is P, product of mass into velocity. This is linear momentum. Now when I say angular momentum, it is m into v into r. R means radius of a cell, because the shell is not linear. Linear means not straight. It is not straight. Shell is circular, you can see. So circular means it will have a radius. This is a radius from the nucleus. It will have a radius. So you have to put the value of the radius. Then you will be getting the angular momentum. So the angular momentum is also quantized, whose value was given by Niels Bohr as nh by 2 pi. But from where this value has come, Niels Bohr could not say. He could not say. Later on, it was said by another scientist. You read it later on. It was said by another scientist from where he got this particular value. This was just assumed by Niels Bohr. See, previously the scientists, they used to assume something. And their assumption was so powerful, it was so correct, that later on when this value was calculated by some other scientists, they found it was more or less correct. In this way, when you will study science, you will see that, you will say that assumption, yes, they were such powerful. Alright, they used to think, their logic was so powerful, so great, because they did not used to mug it up, understood? They used to think and they used to say all these things. It is not that whatever it came to his mind, like yesterday in the night he dreamt something and from the dream somebody came and said, see, the value is nh by 2 pi, you write it down. It's not in that way. When they told something that was having some logic, even if they could not prove at that particular time. Why they could not prove? The reason is that whatever the resources was available at that time, it was not sufficient for them to prove. For that reason they could not prove it. But later on when the other scientists they proved, they found that it has been correct. So Niels Bohr could not prove it, but he assumed a particular value. Value of the angular momentum, he assumed mvr is equal to nh by 2 pi. And its value is also fixed. It is quantized. It is not any value of its own. It cannot be any value. Theoretically it can have any value. But as I said you, practically, you cannot have any number of shells. You can have a definite number of shells, a fixed value. That is a whole number. Alright, you cannot have any particular number. Remember all these things. So next is that, as I said you, electrons is moving in its shell. Niels Bohr suggested that. Let me just wind up the Niels Bohr's atomic model. He said that we are having a nucleus and electrons is moving in a particular shell whose value means energy, is fixed or quantized. It cannot have any value of its own. Its value is definite. And the first shell is known as the what you can say, having the lower energy level, and the electrons which are present in the first shell, they are said to be in the ground state. After that, when you move from the nucleus, the energy increases energy, gradually it increases, does not decrease, it increases. Alright, fine. Now next is the outermost shell is considered to be as the valence shell. We can say it is a valence shell, outermost shell. And the electrons which are present in the outermost shell are considered to be as a valence electrons, and they determine the chemical properties of an atom. because the sharing, the transfer of electron takes place, that is a loss or gain of electrons, all takes place from the outermost shell only, not the innermost shell. Because the innermost shell, the electrons are the bound electrons, and the outermost shell, the electrons which are present, they are considered to be as the free electrons. So they determine the properties of an atom, of an element, we can say that. Clear? I hope you understood the Niels Bohr's atomic model. Now, as I said you, that Niels Bohr suggested that we are having shells around an atom, around the nucleus. Got it? And I said you also KLMN in this way. So he gave us the electronic configuration. Electronic configuration is what? It is nothing but the distribution of electrons in different shells in an atom. Got it? Distribution of electrons in different shells of an atom is called the electronic configuration of the atom. The distribution of electrons, that in a particular shell, how many electrons is there? It cannot be any number, because as I said you, electrons remains, Niels Bohr suggested that the electrons in a given shell, it continues to remain in that particular shell unless and until some external energy is provided to it. So it will infinitely remain in that particular shell unless and until you provide some energy to it. Alright? So hence, a particular shell has got a definite number of electrons also. It has got definite energy, and the electrons which are present in a given shell has got that much amount of energy. Suppose if an electron is present in the first shell, so the electrons which are present in the first shell, they will have the energy of the first shell. Electrons which are present in the second shell, they will have energy of the second shell. Electrons which is present in the third shell, they will have the energy of the third shell. In this way it goes on. Okay. Now, how many electrons are there in a particular shell? Now, this particular, what you can say, it was given by, the concept was given by Bohr and Bury, the two scientists. It is known as Bohr-Bury scheme. They gave us a scheme. According to that particular scheme, the number of electrons in a given shell, the maximum number of electrons in a given shell is given by the formula 2n square, where n is equal to number of shells. What I said you? The maximum number of electrons in a given shell is given by the formula 2n square. That means if I use this formula, the K shell will have 2 electrons. K means n is equal to 1. Isn't it? Now L shell will have how many electrons? You put the value of n as 2. L means what? N is equal to 2. Alright, so what you will get? 8 electrons. In this way, n is equal to 3. You put it. You will be getting as 18 electrons. In this way, you will get 32 electrons in this way. Why I am putting minus charge? Because electron is negatively charged. Or that is when I am putting it. You know that. In this way, the first shell consists of 2, then 8, then 18. So we came to know that this is suppose a nucleus, and the first shell which contains how many electrons? 2. The second shell contains how many electrons? Maximum. This is maximum. Minimum it can be anything. It can be 1 also. Like first shell, the minimum can be 1, but maximum it cannot be 3. Maximum is 2. Understood? So here the maximum is 8. 8. In this way. See, this arrangement which I am doing it is known as the electronic configuration of an atom. This is the arrangement of electrons in a particular shell is called as the electronic configuration. This is known as the electronic configuration. That the first shell 2 maximum, second shell 8 maximum, third shell 18, then fourth shell 32 in this way. This is the first point. Alright, given by Bohr-Bury. Now second point is very important. If a particular shell is the outermost shell, any shell, it can be third shell, fourth shell, fifth shell, any shell is the outermost shell. The maximum number of electrons in the outermost shell is 8 only. It cannot be more than 8. It cannot be more than 8. Whichever is the outermost shell, the maximum number of electrons will be 8 only. Alright, clear now this particular thing? Now, next is when you write the electronic configuration, you will come to know. I will teach you now the electronic configuration. The next thing is that when you are filling of a particular shell, the first shell is filled, let us say 2 electrons, second shell is filled 8 electrons, third shell is filled 18 electrons. Alright, now remember here that when you are filling a particular shell, you must remember it that it's not that you are filling a shell and it is going on, the electrons is being added. You have to remember here that the outermost shell should not exceed 8 electrons. The outermost shell should not exceed. Even if in the third shell the capacity is 18, but the outermost shell, if the third shell is outermost shell, then it cannot have more than 8 electrons. Alright, so you are not supposed to fill accordingly. Like suppose the third shell, sir, you said 18, so hence first we will fill up the third shell, then we will see that anything is left, then we will go to the fourth shell. No, as the what you can say, the third shell becomes the outermost shell, 8 electrons is filled, automatically the fourth shell will be created, because the remaining electron will go to the fourth shell. In that particular way it is being done. Alright, for example, let me give an electronic configuration. Like potassium atomic number is 19. Achha, before potassium, let me tell you how to write the electronic configuration of different element. Let us say oxygen 8. So it will be 2, 6. How 2, 6? Because first shell is 2, then remaining is how much? 6. The second shell is 6. Maximum capacity is 8, na? So 6 it is. Now, next, sodium 11. First is 2, second cell is 8 maximum, so 8 plus 2 is 10. One more is remaining, total is 11. Na? So 2, 8 and third cell will be how much? 1 in this way. Alright, suppose that is sulfur 16. So first shell is 2 maximum, second shell is 8. Alright, so 8 plus 2, 10. So remaining is 6 in this way. It is being done in this way. Alright, now let us come to 19 potassium as I was saying. So first shell is 2, second shell is 8, third shell is 9. Third shell is 9. So 2, 8 to 10, 10 plus 9. But can it be 9? No. Because what I said you? If the third shell or any shell is outermost shell, the maximum number of electron is what? 8. So it is 2, 8, 8. Then automatically the fourth shell is created. That is 1. That's what I was saying you. It's not that the third shell will be filled up, then the fourth shell will be. No. If the third shell is outermost shell, then it will have 8. Then automatically the fourth shell is created. That is, for 1 electron goes to the fourth shell. In this way, that you have to remember it. The second point, which is very important. So let us say that is calcium, atomic number 20. So 2, 8, 10. Then it should be 10. 10 is left. So should we write 10? No. 2, 8, 8. Then 2. Because if you write 10, it's not possible. Why it's not possible? Because 10 is the third shell is the outermost shell, and outermost shell cannot have more than 8. It cannot have. So hence this will be 8. The remaining is what? 2, 8, 10. 10 plus 8, 18. So the remaining is 2. So 2 is the outermost shell. 2 is the valence shell. So number of valence electron in here it is 2. Here the number of valence electron is 1. Here the number of valence electron is 1. Here the number of valence electron is 6. Here the number of valence electron is 6. Just now I said if an element have 1, 2 or 3 valence electrons, then it will have a tendency to lose. It is a metal. Now why it will have a tendency to lose? Why it will have a tendency to lose? Because always an atom tries to attain stability. Alright, always an atom, now listen carefully, always an atom tries to attain stability. How it will become stable? When the outermost shell is fully filled. When the outermost shell is fully filled, that is, it has got either octet or duplet configuration. Duplet means if the outermost shell has got 2 electrons, that is said to be duplet. And if the outermost shell has got 8 electrons, that is said to be as octet. So if the outermost shell has got either octet or duplet configuration, then it is said to be, what you can say, fully filled. Now you might say me, that's a, now you're saying that is outermost shell should be octet. Where from duplet came? Duplet means, see, there are 2 elements are there, which has got only one shell. What is that? 2 elements, hydrogen and helium. So hydrogen atomic number is 1, so it is 1 shell. Helium atomic number is 2, so it is 2. Alright, it is 2. It's having only 1 shell. So the element or the atom which has got 1 shell, from where octet will come there? From where octet will come? Octet will come from the second shell. The rule of octet comes from the second shell. So if an atom has got 1 shell, then it will follow definitely a duplet configuration, because it has got 1 shell and the first shell is fully filled. Done. Understood now? So hence, for that particular purpose, here what I say, listen carefully. Here sodium is having 1 electron in the outermost shell. To attain stable configuration, it will lose 1 electron. Then outermost shell becomes stable, 8. Here an atom has got 6 electrons in the outermost shell. So will it lose 6 electrons or will it gain 2 electrons to attain stability? Definitely it is going to gain 2 electrons, because that's easier. What I said you, will it lose 6 electrons? Because if it is losing 6, it becomes duplet. If it is gaining 2, if 6 plus 2, if it is gaining 2, then the outermost shell becomes 8, octet. So which is easier, to gain 2 or to lose 6? To gain 2, definitely, lower number. So hence, for that particular purpose, it gains 2 electrons. Gains. So, gains, which element gains electrons? Non-metals. Oxygen is a non-metal, it's a gas. Sulfur is a non-metal, it's a also on heating it changes into gaseous state. So what you find is that, so element which have got 1, 2 or 3 electrons in the outermost shell, like here you can see 2 electrons is there. If it is losing 2, then the outermost shell becomes octet, fully filled. It becomes stable. Alright? To attain stability, because everything in this world wants to attain the stable configuration. Even you also wants to attain stability. Suppose if I ask you to stand in one leg, you will not be able to stand for a long time. Why? Because it will be unstable. The center of gravity will fall outside your body. You have read in physics this thing. So hence, to attain stability, you need to stand in two legs. That's it. And if you still want stability, then you need to sit in a chair, a short, height chair. According to your height, you need to sit on a chair. Then you will become fully stable. We can say that. Clear? That's it. So here also same thing. And this element, it is unstable in nature. So it will lose 2 electrons and it will become stable. Because the outermost shell is fully filled, it becomes, see, 8 electrons outermost shell, it attains the octet configuration, becomes stable. Are you following? So hence it has got a tendency to lose 2 electrons. So calcium is what? Metal. Potassium is what? Metal, because it is losing 1 electron. Here also it will lose 1 electron and becomes stable. The outermost shell becomes fully filled. So in this way, the elements which have got a tendency to lose electrons. So which element will have tendency to lose electron? 1, 2, 3. They will have a tendency to lose, because by losing electrons it attains the octet structure. You can see it here, you can see it here, you can see it here. And here it has got a tendency to gain by gaining electrons. One more example I will give you. Nitrogen, let us say 7, 2, 5. It has got a tendency to gain. Like chlorine, 17, 2, 8, 7. It has got 2, 8, 7. It has got a tendency to gain. By gaining 1 electrons it becomes stable. By gaining 3 electrons it becomes stable. So if an element has got 5, 6 and 7 electrons in the outermost shell, it has got a tendency to gain. So it is a non-metal. And if it is having like carbon 6, 2, 4. So 2, 4 means 4 it can lose, 4 it can gain. So it is a non-metal. And neon, let us say, it is 10 atomic number. So 2, 8. So 8 means it is fully filled. Alright, argon, it is 18. So it is 2, 8, 8. Again outermost shell is fully filled. So it is stable. Here it is stable. So it is consisting of inert gas, noble gas. It has got zero reactivity. Why it is not going to react? Because the outermost shell is fully filled. Why it is going to react? Here the outermost shell is not filled. Here the outermost shell is not filled. Here it is not filled. Here it is not. Here it is excess filled. So here it is going to lose. Here it is going to gain. But here what it will do? No lose, no gain, nothing. So hence it is inert. Here also same thing. Inert. So they are inert in nature. They are said to be as. Alright. In this way we can say the electronic configuration. Thank you very much.